Hallo, it's Dumplet here. Here's an item on Combinatorics. R is a set of 6-digit positive integers n, such that n is even, n leaves a remainder of 7 when divided by 9, and let us say s of n be the digit sum of n, then s of n is equal to s of n. Or in other words, the sum of the digits of n is equal to the sum of the digits of the sum of the digits of n. Now we're asked the cardinality of R, so the number of elements in set R. Now this item came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so the main thing about n is that it's a 6-digit number, and we're given with like 3 properties of n. So let's try to take a look at these properties individually. Let's start with the sum of the digits property. So let's just say the 6-digit number is A, B, C, D, E, F. Those are the digits from left to right. Now let's try to observe on the sum of the digits of n first. So S of n. So well, S of n will just be equal to A plus B plus C plus D plus C plus F. All right, now let's try to bound this thing. Now there is an upper bound. Now obviously the upper bound is when all of the digits are 9. So largest possible value, 6 times 9, that's going to be 54. Okay, now take a look at 54. It's a 2-digit number. So that just tells us that, okay, the sum of the digits is at most a 2-digit number. Now let's break this down into I'm gonna say a simpler format, because I'm gonna propose we can rewrite this one, the sum of the digits, as I'm gonna say 10x plus y. Now I'm going to set that x and y are just non-negative digits, so non-negative digits from 0 to 9. Now why can x be a non-negative integer? It's because, well, if x was 0, I'm considering the case that y is the sum of the digits is a 1-digit number. Now, obviously, if x was positive, then 10x plus y would represent a 2-digit number. So that kind of takes care of everything here. So the sum of the digits of n, let's just say it's equal to this 10x plus y. So, all right, I'll have 10x plus y. That's the sum of the digits of n. And then, well, 10x plus y is a 2-digit number, xy. Okay. Now, obviously, if x was 0, then it's going to be 0y. So technically just a 1-digit number, but this is fine. We're taking both cases here. And the sum of the digits of n is essentially now x plus y. Now, taking a look at this equation, the y cancels, and I'll get 10x equals x. And from here, actually, I'm going to get x equals 0. Right. Now, what does x equals 0 tell us? X equals 0 just gives us y as the digit sum. And since we let y to become just a digit from 0 to 9, we can safely say from this part that the sum of the digits of n, it must be a 1-digit number, right? Because the tens place must be 0, right? So it's going to be a 1-digit number. Now, combining this fact with the second, the condition of the remainder, n leaves a remainder of 7 when divided by 9. Now, a lot of you guys might recall that the divisibility rule for 9 is to just take the digit sum and check whether or not it's divisible by 9. Now, a nice property about this is that, well, the remainder when this number is divided by 9 is actually just the same as the sum of the digits of the number. Now, to kind of show you guys it to kind of represent this, let's go back to the generic A, B, C, D, E, F, the 6-digit number. If I'm going to write it in terms of like a sum, it's going to be 10 raised to 5 times A plus 10 raised to 4 times B, so on and so forth until the F. Now, if I were to take this under mod 9, well, all the 10s are congruent to just 1s, so all of this just become 1 raised to 5, 1 raised to 4, 1 raised to 3, 1 raised to 2, and then just 1 with the A, B, C, D, E, and F here. So, well, 1 to any power is just 1 anyways. So we're going to have here that, well, the original thing, the 6-digit number, is just congruent to the sum of its digits, A plus B plus C, A plus B plus C plus D plus E plus F. And this is under mod 9, right? So Well, what does this tell us? N leaves a remainder of 7 when divided by 9. And we found out that, well, the remainder is just the sum of the digits of n. And, well, the sum of the digits of n must be a one-digit number. So we can try to see now, we want a one-digit number that leaves a remainder of 7 when divided by 9. So that gives us a very good hint as to what this must be. Well, it can only be 7. It's a one-digit number that leaves a remainder of 7 when divided by 9. It must be 7. So we must have the sum of A to F is 7. And lastly, we're going to use the condition that n is even. All right? Now, n is even really just forces F here, which is the last digit based on our representation, to be even. Okay? Now, taking a look at this actually, we have a sum of some variables equaling to 7. Now, a lot of you guys might think of this thing, the stars and bars. So the stars and bars, also known as balls and urns. So I like to call it stars and bars, but balls and urns is just an alternative name for it. So we're going to try to apply stars and bars to this question, but we have to take care of the restrictions first, because A to F, well, they're non-negative except for A, because A is the leading digit. So we're gonna do what we call as kind of saving. I'm gonna write A as A prime, and I'm gonna do the saving here. I'm gonna subtract 1 here. So essentially, I would have to solve for non-negative solutions to A prime plus B plus C plus D plus E plus F, and that's gonna be equal to 6. All right, that's the thing I'm gonna solve. Now, F is an even number, so we have to kind of take cases here. Well, F can only be 0, 2, 4, or 6, because obviously the sum of everything here must be 6, so it can't be greater than 6. So we just kind of take it one by one. So for example, if F was 0, then the sum of A prime to E over here, it's going to be 6. If F was 2, it must be 4. If F was 4, this part must be 2. If F was 6, then this part would have to be 0. So we just have to kind of solve for this one, because that's just simple stars and bars with no restrictions. So we have 4 possible cases. So we've taken care of the F. We just have to solve for the number of solutions in this part. All right. So we just have to solve for non-negative solutions here. Again, A prime, B, C, D, and E, they're non-negative. They can't exceed 6, so no problems here. All right. So in the first case, it's going to be the number on the right. In this case, 6. 6 plus, I like to think of this as adding the number of plus signs. So it's going to be 4 plus signs. So 6 plus 4, and then I'm going to choose the number of plus signs. So 6 plus 4, choose 4. Now, in effect, that's just 10 choose 4, because 6 plus 4 is 10. And then we just have to get what's 10 choose 4. Now, 10 choose 4, if you evaluate that, it's going to be 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. We can cancel all of the things here. The 8 cancels out, the 9 and the 3 cancels nicely. So we're going to get an answer of 210 for 10 choose 4. Right? So 10 choose 4 is 210. We just do similar stars and bars trick to all these 3 solutions, and we're going to get 8 choose 4 for the case where the sum of A prime to E is 4. And then this gives us 6 choose 4, and then this gives us 4 choose 4. Right? Solve them individually. 8 choose 4, we're going to get that 8 choose 4 is equal to 70. 6 choose 4 is 15. 4 choose 4 is 1. And then we just take the sum of everything. So 210 plus 70 plus 15 plus 1. That's going to give us 296. We're done with the cases here, and we added them up. So there we go. There are 296 possible numbers based from our observations from start to finish. So that's going to be the cardinality of set R, right? So 296 is our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye.